Alright, put your pencils down, guys. You don't want to copy off of me because you want to make sure you can go back and get the practice of doing these problems yourself. But I'm happy to help you out. This lesson is obviously about hyperbolas. We're going to be checking those out today. And let's get started. Hyperbolas generally look like this. They have two branches. Okay? They're not parabolas, but they have the same basic look to them, but they come in pairs. Sometimes they are horizontal, opening to the left and to the right, like this one. And sometimes they are vertical, opening up and down like this one. Okay? These points here are the vertices. So this is a vertex and this is a vertex. The distance from the center to the vertex, we're going to call that A. And now you see this rectangle forming in here, and we'll talk about that more in a minute. But the distance from the center to the side of the rectangle that doesn't have a vertex, that's going to be B. Okay, we will call this the co-vertex, even though it's not actually on the hyperbola at all. Also, a hyperbola has two foci, or foci, and there are going to be a distance called C away from the center. Now, when we dealt with ellipses, A was always bigger. For hyperbolas, that's not true, okay? Sometimes the A value will be bigger, sometimes it'll be smaller. It depends on other things. Now, the equation is very similar to the equation for an ellipse. The difference that you're going to notice is that for an ellipse, this would be positive, but for a hyperbola, it's negative. The rest of it really looks the same. Okay, now just keep something in mind though. For an ellipse, we always put x first and then y. For a hyperbola, because of this subtraction, one term is going to be positive, which we always put first, and the other term is going to be negative. The positive term tells you whether the parabola is going to be horizontal like this one or vertical like this one. All right, if the positive term is the x term, then it's going to be horizontal, the x direction. If the positive term is the y term, then it's going to be vertical, opening up and down like the y direction. Also, the positive term tells you which one is your A value. I told you, unlike the ellipse, A is not always bigger, but A is always with the positive term. Okay, so the vertices will always go with the positive term, and that's your A value. Your B value will always be from the negative term, and that will give you your co-vertices. One more main thing to point out to you. Basically, these are all saying what I was just saying to you. The relationship between the A, the B, and the C. For hyperbolas, C squared is equal to A squared plus B squared, just like the Pythagorean theorem. When we did ellipses, it was A squared minus B squared, so you have to get used to that difference. Okay, and the diagonals of the box that's formed by our A and our B, these diagonals are asymptotes, and so the hyperbola will get closer and closer to these asymptotes the further out they go. Okay, that's the background. Now let's zoom in and take a look at number one. Alright, looking at this equation, we can tell many things right away. First of all, pay attention to which is the positive and which is the negative term. Because the x term is positive, I know this is going to be horizontal. Okay, the positive term is always going to give us our A value. So our A value is 5. And that A value is always going to give us our vertices. Okay, on the other hand, the negative term is always going to give us our b value. It doesn't matter which one is positive. And the b value will give us our co-vertices. Okay, so the positive one is where the vertex comes from. The negative term is where the co-vertex comes from. So let's go ahead and make that box. So let's start with the vertices. So I'm going to go 5. Now, like I said, this 5 is with the x values, so we're going to go horizontal with it. Oh yeah, first of all, the center. I almost forgot. That's the first step. The center is 0, 0. You can tell because it's just x squared. If it was like x plus 3 squared, and then let's say y minus 1 squared. If it was this, then the center would be -3, 1, opposite, opposite. But since it's just x squared and y squared, that means it's 0, 0. So let's go ahead and knock that out. So the center is 0, 0, and we can write that down. All right, now the vertices. I'm going to, from the center, I'm going to go left 5 and right 5. 1, 2, 3, 4, 5. Vertex. 1, 2, 3, 4, 5. Another vertex. And again, I knew I would go left and right because it's with the x values, and the x values go left and right. Okay, so those vertices are -5, 0 and 5, 0. All right, the co-vertices, like I said, are going to come from the b value. This is going off the grid. Isn't this only 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 11 is going to be all the way at the arrowhead. Okay, so these are the co-vertices. All right, so that's 0, 11 and 0, -11. Okay. Now I want to go ahead and draw that box I'm always talking about right now, the rectangle. Okay, and it's going to go like this. Let's see, I think I'll make my rectangles green. Your rectangle should be dotted, guys, just like the asymptotes will be. Okay, just a couple small adjustments here. Okay. All right, now the main purpose of the rectangle is to illustrate where the asymptotes are. Okay, so we will have asymptotes going through the diagonals of this rectangle. So this is going to be an asymptote. And I'm going to have an asymptote going the other way as well. Okay, so those diagonals are my asymptote. I might have to make them longer. Stand by. All right, take a quick glance. I felt like I needed to stretch those asymptotes out because I'm really going to need to see where these branches go. And if the asymptotes don't reach out, there will be no curving. So this is going to be pretty big. Deal with it. Anyway, for the foci, we need the c value. So remember that c squared is equal to a squared plus b squared when it comes to hyperbolas. So this means c squared is going to equal to 25 plus 121. So let's see. So that's 146. Yeah. So that means c is going to equal the square root of 146. Now that is approximately 12.1. Okay, man, this thing is really off of this graph a lot. So so this is 10, so 11, 12 would be right about here. Okay, same thing over here, 11. Okay, so these are your foci are going to be like off the grid about there. Okay, now as far as naming them, I'm not allowed to use these decimals, okay? And square root of 146 is already, it doesn't simplify any more than that. So just keep that in your head, radical 146. So really, considering that we started from 0, we're going to go 0, and then we're going right radical 146, and left radical 146. So as far as my x values go, it should be positive radical 146 will be the x value of this point. And it's on the line, so the y value is 0. So radical 146 comma 0, and then negative radical 146 comma 0. Foci are often ugly. Deal with it. Okay, now we're going to do the asymptotes. Now, to do the asymptotes, we are going to, instead of using y equals mx plus b, which is called slope-intercept form, we are going to use a different form of the equation called point-slope form. And it's going to work sort of like this. It's going to be like y minus y1 is equal to the slope times x minus x1. All right, now x1 and y1 can be any point on the asymptote. Okay, I recommend always using the center. Yeah, just use the center because that's going to be a point that's on both asymptotes, and we can double down. Now, the slope, let's see. Well, the rise is 11, and the run is 5. So 11 over 5 is the slope of this line. All right, 11 over 5. Now, this one going the other way is going to be slope negative 11 over 5. Maybe I should put it out here. 11 over 5 and negative 11 over 5. So that's always going to happen. They'll be the same, only one's positive and one's negative. So what you can do to capture them both at once is just go ahead and put plus or minus 11 over 5. So it's really, you're writing the equation of both asymptotes at once. Now, using that center value of 0, 0, okay, this is my x1 and this is my y1. So we're going to take those zeros and plug them in. Okay, so if we do that, then we're just going to have 0 and 0. Okay, now if you left it like this, I would give you full credit. A mathematician would not write those zeros and leave them there, okay, because they're not causing any change. So a more sort of professional way of writing the equation would be to just write y equals plus or minus 11 over 5x. Okay, asymptotes. All right, so we've filled in all the facts. All that's left is to do the graph. I'm going to zoom out a little because this is so big. Okay, so you know that the branches should be approaching the asymptote. So this is going to be a very wide branch. And, oh man, I messed up. This is tricky with an electronic pen. Let me try again. So it's going to be very wide as it approaches the asymptote. Okay, so it's you can hardly see the curvature, but that is in fact what is happening. All right, so it's like that type of thing. Let me try one more time. This is tough. Okay, so you can get the general idea, but it's just so wide it's really hard to see. Okay, but good enough. Let's move on. Let's do number 2. Okay, once again, I see that the positive term here is an x term. So that tells me that this whole thing is going to be horizontal. Okay? The positive term always gives you your a value, which is 6. And this is always where you can get a vertex from. Okay? Now, this is the negative term is going to always give us our b value, which will just be 1. And this will give us our co-vertex. Okay, so let's go ahead and graph the vertices and the co-vertices right now. Oh, you know what? We need the center first. So the center is going to be the opposite of these, right? All right, so my center is going to be 2, comma, -1. So that's my center. I better write that down. 2, comma, -1, and let's graph it. 2, comma, -1. There's my center. Now, you really had to get that center down before you did anything else, because everything else is based off the center. So when I do this 6, I'm going to move left and right, okay, because it's with the x's, and x's go left and right, but left and right from the center. So 1, 2, 3, 4, 5, 6. There's a vertex. 1, 2, 3, 4, 5, 6. There's a vertex. Okay, how about those co-vertices? Well, it's going to be pretty narrow because the b value is 1. So that just means up 1, down 1. All right, I should be naming these things while I'm at it. Okay, so vertices. So this one on the left here is, let's see, 1, 2, 3, 4. -4, comma, -1. Okay, the one on the right here is 8, comma, -1. All right, now the co-vertices shown here in blue are the points 2, comma, 0. And 2, comma, -2. Okay, how about the foci? Let's talk about the foci. Well, the foci come from the c value. All right, I should erase this. That c stood for center, but it might remind somebody of foci, so I'm going to erase it. Okay, we all know that c squared is equal to a squared plus b squared when we're dealing with hyperbolas. So that means c squared is equal to 36 plus 1. So c squared is equal to 37, which means c is equal to the square root of 37, which is approximately equal to, let's see, square root of 37, it's approximately equal to 6.1. Okay, so as far as graphing it, we will travel 6.1 from the center, okay, and it's obviously it's going to be horizontal just like the vertices. So this was 6. All right, so the focus is going to be 6.1 away, so that's barely anything. So that's going to be just touching on the outside. Okay, that's pretty weird, but that's the way it is. Now, in terms of showing, listing what the foci are, we are not allowed to use the 6.1, okay? What we have to do is use this radical 37. So starting from the center, okay, as we look to the left and to the right, the x value of the center is 2. So we start at 2 and then we go to the right radical 37. Okay, so that first one is going to be x value of 2 plus radical 37. The y value is simply -1 because it's down 1. Okay, and the other one's just going to be 2 minus radical 37, comma -1. And look at it one more time. Try to understand this really, a lot of kids have trouble with this. I'm trying to get to this green dot. I'm trying to name the x value of it. I mean, obviously it's like -4 point something. But we're not allowed to say that because we have to be exact. So the only thing you can do is start from the center, which is x value of 2. And if you're moving to the right, you add. If you're moving to the left, you subtract. So this is 2 minus our radical 37. Okay, and the y value, of course, is -1 because it's down 1. So that's the trickiest part for a lot of students. I hope you understood that. Now, the asymptotes. Again, let's use our our point-slope form, which is like y minus y1 is equal to the slope, and we're going to wind up doing like a plus or minus slope, times x minus x1. I guess we never really need these parentheses, so I'm just going to get rid of that. So this is the model that we're using to find the asymptotes. Let's get the slope out of the way. Well, you know what? It's time to make that box. So the box is going to be like this. Whoa, that is not how the box is going to look. Let me try that one more time. If I fail again, I will do it off camera. Okay, so here is the idea. Okay, there's my box. Now, my asymptotes are going to be the diagonals of this box. So I'm going to have a diagonal doing like this. Should I make these longer? Yeah, I'm going to make them longer. Okay, let me just stretch. Whoa! Okay, so there's our rectangle with our asymptote. So now we can see how the slope is working. So looking at the positive one, okay, you can see that the rise is like it's up 1 and over 6. All right, it's not a coincidence that it's the A value, it's the B value and the A value. So always look for these numbers to be part of your slope. But in this case, it's up 1 over 6, rise and run. So slope of 1/6. Okay, and of course this one has the slope of positive 1/6, and this one has a slope of negative 1/6. Put them together, and there's your slope of plus or minus 1/6. Now, we need a point to be our x and our y, all right, our x1 and our y1, and I recommend using the center. Okay, so check it out. Our center here, of course, is the point 2, comma, -1. So let's let that be our x1 and our y1. So x1 is 2, y1 is -1. Okay, so x1 is 2. Okay. And y1 is -1. So that's going to become +1. All right, so it's the opposite, like we do many things, okay? A positive 2 becomes -2. A -1 becomes +1. And guess what? That's it. We can leave our asymptote equations in this form. Y + 1 equals ±1/6 x - 2. I think that's the easiest way to do it. Let's go ahead and finish off this graph. We just need to draw the branches of the parabola. Remember, these pink dots were our vertices, and so let's not forget that. Okay, and so we're going to just stretch these out, and as they have them approaching the asymptotes. See if I can do any better with that one. Okay, so kabam, your graph should look like that. All right, that is it for number 2. Let us move on to number 3. Okay, once again, the positive term is where all the action is. Because the positive term is a y, I know that this time it's going to be vertical. Okay, the positive term gives me my a value of 3, which is where I will get my vertices from. Okay, the negative term is going to give me my b value, which is 10. This is where my co-vertices will come from. Okay, and the center. Let's talk about the center. The center will be the opposite of these, but be careful. The y is on the left, the x is on the right, but still, the x coordinate needs to come from the x. So the opposite of this is -3. So when I do my center, that -3 goes first. Some kids mix that up because they're out of order. The y, because it's just y squared, is going to give us a 0 for the y coordinate of the center. So there's your center. And that's -3, 0 is right here on this line. Okay, there's my center. So now let's do the vertices and the co-vertices. Okay, my vertices, I will go 3 in the y direction, so vertically. So from the center, I'm going to go up 3 and down 3. All right, those are my vertices. So by the way, that's -3, comma 3. And -3, comma -3. Now my co-vertices. My co-vertices, I will have to go 10 in the x direction because the b value was with the x's. So I will go 10 to the left and right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 7, 8, 9, 10 would be about there. Okay, so my co-vertices are, okay, let me get this one first. That's 7 comma 0 is one of them. Okay, this one I had to go off the grid for it. See, that's 10, and I went like 3 more off the grid. All right, so that's negative 13 comma 0. Okay, this we'll be able to use this to make our box later. Let's get the foci first, though. Okay, so for the foci, that's where we do the c. We need the c value. So here we go. We know that c squared is equal to a squared plus b squared. So c squared is equal to 9 plus 100. So c squared is equal to 109. So c is equal to the square root of 109. Does that simplify at all? Nope. But the decimal approximation is 10.4. Okay. I went ahead and drew the rectangle and the diagonals off camera, but like I was saying, the foci, this 10.4 will help me place each focus. Please remember that this is going to be a vertical hyperbola, so the branches, look at these vertices, the foci should be right in line with the vertices. So when I go 10.4, okay, I'm counting from the center. You don't count from the vertex, you count from the center. So here's 10 right here, so 10.4 would just be a little bit above that. So there's a focus. And then same thing here, if from the center, if I go down, here's 10, so 10.4 would just be a little bit below that. Okay, and since I've drawn the diagonals, those are the asymptotes. So now would be a good time for me to go ahead and draw these branches to the best of my ability. Once again, these are very wide open branches. Okay, they're going to be looking something like that. Okay, it's hard to draw them when they're this wide, but just do your best. Do your best. They're very wide. That's okay. Something like that is fine. All right, now, what else? Oh yeah, so naming the foci. We got to name them, and we can't use the 10.4. Actually, this will be pretty easy because we're starting from 0 anyway. So, all right, let's start with the x value because that's super easy. Okay, take this top one. The x value is -3, all right, because it's left 3 and up 10.4. So, but that x value is definitely, yeah, don't pay any attention to that. The x value is definitely over at -3. So we're going to have -3, comma. Now, the y value, we're starting at 0, and we're going up radical 109. We can't say 10.4. So 0 plus radical 109, obviously we don't have to put 0 plus. We can just put radical 109. Now, if this y value had been anything other than 0, let's say if this had been a 1, then I would have put 1 plus radical 109 and 1 minus radical 109. But when it's 0, you don't need to put the 0. Anyways, so that's one of them. And the other one is also going to be at an x value of -3, as you can see. But it is down radical 109. Okay, so those are the foci. Now for the asymptotes. The easiest thing to do is to use point slope form, which works like this. Y minus y1 is equal to the slope times x minus x1. The y1 and the x1 are a point on the line. I don't know why I keep putting these parentheses in here. They're not needed at this point. Yeah, so let's start with the slope. Now, looking at this upward sloping line, okay, and keeping in mind that the slope is going to involve the 3 and the 10 here, okay? Maybe you can easily see that what's happening is we're going up 3 and over 10. That's how we formed this box in the first place. So up 3 over 10. So 3 over 10 is the slope for the upward sloping line. So slope 3 over 10. Of course, the other one is going to be the same, only it's going to be negative 3 over 10. So we can do both of these at once by writing for the slope plus or minus 3 over 10. Now, for the point, I recommend using the center. Okay, so I would take this, the point negative 3, 0, and substitute this as our x1 and our y1, since that's the one point that is on both asymptotes. So use it. So if I let y1 be 0, that's this guy, okay? So this would become 0 suddenly. If I let x1 be negative 3, then this would become positive 3, plus 3 right here. See how it's like the opposite? Minus 3 becomes plus 3. Okay, and if you left it like this, I would give you full credit. A mathematician would not put the minus 0. All you would see is plus or minus 3 over 10 times x plus 3. Alright, now understand that's the equation for really two separate asymptotes, one with a positive slope and one with a negative slope. But anyway, that's it. That's how you do problem number 3. Okay, let's take a look at number 4. Alright, the y term is the positive one. So right away that tells me that this is again going to be vertical. Alright, my a value is going to be 5. And that's where I get my vertices from. My b value is going to be 4. That's where I get my co-vertices. Also, the center is going to be the opposite of these, but please pay attention. The x value is over here, the y value is over here. X comes first. So positive 2, negative 3 for the center. The center will be positive 2, comma, negative 3. Don't get it twisted. Alright, the x value is on the right, so you have to sort of crisscross and bring it over here to the left. Let's graph that center. 2, comma, negative 3 is right here. So now let's do our vertices. Our vertices, so we'll go 5 in the y direction, so 5 vertically from the center, so that's 3, 4, 5. There's a vertex. And there's 3, 4, 5. There's another vertex. So 2, comma 2. And 2, comma negative 8. Alright, the co-vertices will come from the 4. And since this comes from the x term, I will go left and right 4. Okay, so here's a co-vertex, and here is a co-vertex. So negative 2, comma, negative 3 is 1. Okay, and 6, comma, negative 3 is another. Now for the foci. For the foci, we are going to have that c value. Okay, so remember, c squared is equal to a squared plus b squared. For hyperbolas. For ellipses, it was minus. It's not just your imagination. C squared is equal to 25 plus 16. A squared, b squared. C squared is equal to, what is this, 41? Which means C is equal to the square root of 41, which is approximately equal to 6.4. Okay, when we use our C value to place the foci, we have to count from the center, and the foci should be in the same direction as the vertices, these pink dots here. So 6.4, counting from the center. So there's 3, 4, 5, 6.4 would be about here. Should be the same thing here. All right. So there are my foci. Now, when I name them, I can't use the 6.4. I have to use the radical 41. All right. But this is not positive radical 41. Okay, otherwise it would be up here at 6.4 somewhere. No, it is starting from a negative y value and going up. So it's starting from negative 3, and then it's going up 6.4. It's starting at negative 3, and then we're adding radical 41. Okay, so this top point, well, first of all, the x value is 2, plain and simple. Both of these points are over 2. So the foci are definitely going to be 2 comma something. But for the y value, moving up and down, it is negative 3 plus radical 41 for the upper one. And the other one will be 2 comma negative 3 minus radical 41. Okay, that's it for the foci. Now for the asymptotes, I'm going to go ahead and draw the box between the vertices and the co-vertices and the diagonals off camera. Okay, so you can draw your rectangle using your vertices and your co-vertices, and the diagonals will form the asymptotes of the hyperbola. Now, as far as the equation, once again, we are going to use point slope form, which works like this. Y minus y1 is equal to the slope times x minus x1. Okay, now the slope is always going to involve the a and the b, so just watch out for that. Okay, so this is what? This was up 5 and over 4, right? That's your rise and your run, up 5 over 4. So this positive slope is positive 5 over 4. Of course, the negative slope is going to be the same thing, only negative, so negative 5 over 4. Okay, so we can put those together in one slope here by putting plus or minus 5 over 4. Okay, I recommend using the center as your x1 and your y1. So I would let this be my x1, and I would let this be my y1. So x1 is 2 and y1 is negative 3. Okay, so those are going to go in quite nicely right here. Okay, now they will be sort of opposite. So see how this is minus 3 for the y value? It's going to wind up as a plus 3. See how this is a positive 2? With the x, it's going to wind up as a minus 2. So that is a great equation for both asymptotes because of the plus or minus. And you can just leave it like that. Now let's go ahead and finish this off by actually drawing the two branches. Okay, so we see that the vertices are here and here. So we will go ahead and allow these to approach the asymptotes like this. Okay, I feel like I should move that center over so it can be seen better. Whoa, it's dark. It can really be seen now. Okay, anyway, that is it for number 4. Characteristics seems to be spelled wrong. All right, we're supposed to write the equation of a hyperbola with these characteristics. Now, in general, you're going to have to make your own sketches, so just be emotionally prepared to deal with that. So that's what I'm going to do right now. So x-axis, y-axis. So we have vertices at 7, 0 and -7, 0. So, okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we have vertices here and here. Now, that gives us a bunch of information right now. First of all, it tells us that the hyperbola is horizontal. Okay, so the x term is going to be in the front. Okay, so we always have a fraction minus a fraction, and it's equal to 1, right? But my x term is going to be right here. So I'm going to have my x minus h squared here, and my y minus k squared here. Now, it also gives us the a value, which is this. Okay, well, I guess I could have done it over here. Either way, a is equal to 7. All right, because that's the distance from the center to the vertex. So since a is 7, a squared is 49. Okay, and the the a value going to the vertex always comes first in the positive term. We also know the center. Okay, this center right here is clearly 0, 0. All right, halfway between -7 and +7. So that means I'm not going to really have this minus h minus k business. So I can really erase all that and just put, it's just going to be x squared and y squared. Okay, all I'm missing is the b value. But I'm going to get the b value very quickly from the co-vertices. All right, my co-vertices are at 0, 2. Okay, so 1, 2, and 0, -2. All right, so these are my co-vertices right here. So that gives me my b value of 2. So b squared is 4. So there you go. And that's it. That is the equation of the hyperbola with the given characteristics.